Now, anyways, triangle OCD is the image of AOB under a large and centre O, with AO equals 2 and AC equals 3. Find the scale factor of said enlargement, okay? So, what happens is, it's one triangle and it's extended out to the size of another triangle, okay? So we have OBA and we have ODC. Now, ODC is of length 5 and OA is of length A. Now, if I was asked to prove that these are similar, you see that this is a red angle here, red angle here. You can say green angle there, because they're both corresponding. Everybody alright with that so far?
Is A not 2?
Oh yeah, sorry, it is 2. I don't know where I wrote down A there. 2. And then blue angle with blue angle, once again, what's the reason? Our correspondent. Okay? Now, it says because one's enlargement of the other one, they're automatically similar, okay? All eyes up here, guys. Okay? I'll revert back to my previous points, okay? Now, so how much bigger is triangle on the right when compared to triangle on the left?
5 divided by 2.
5 divided by 2, which is 2.5. So it's 2.5 times bigger than the other one. Everybody right with that? So 2.5. Now, the odd thing about this one is, can anybody tell me where the centre of enlargement is here? It's actually on O, because it's actually extending outwards from O. So if I was to draw this, if I was to draw a similar system, okay, so if you, that's a circle. If I was to draw a similar base system, so I'm just going to put my finger there, yeah? And then I was to do the same triangle again. See the way the centre enlargement is actually at O. Okay, so that's to hit that point home. Okay. Now, if OB is 1.8, O to B, what is B to D? B to D, anybody? This one being B and the other one being D.
Multiply 1.8 by 5 over 2.
Yeah, or 2.5. 1.8 by 2.5. You get 4.5, 4.5, okay? Now, what's the ratio of AB to CD? Now that's an interesting one. The ratio of AB to CD. We neither know AB nor C to C. But the ratios of the other sides have to be the same ratio, right? So why don't we just do a ratio of, in this triangle it'd be 2 is to 5. We can take any other two sides because they have to be in the same proportion. For every 2 centimetres AB will have, CD will have 5. Can't guarantee it's 2 centimetres or 5 centimetres, but it'll be in that proportion. Okay? Our triangle OCD is 12.5 square centimetres. Find the area of the triangle OAB. First of all, bigger or smaller? Bigger. Yeah? Oh wait, OAB? Smaller. Okay? Now, does anybody in the class remember what happens with K values and areas? K squared. So, the smaller triangle, if you multiply it by K squared, it turns into the area of the big triangle. Likewise, if I divide by K squared, I can turn the area of the big triangle into the small triangle. So the big triangle is 12.5. If I get 12.5 and I divide it by K squared, what is K squared again? 2.5 squared, or 5 over 2 squared, carefully in the brackets. The answer is 2. So the small triangle will be 2, the big triangle is 12.5. Is everybody on board with this chapter at the moment? This is a very popular chapter, it comes up a lot.
I just think what you did with the ratio thing.
The ratio thing?
Yeah.
Basically, you take a length on one triangle, like 2. You take a length on the other triangle, which is 5. Yeah? And you basically say that 5 is, the ratio is for every 2 centimetres you have on a small triangle, you'll have 5 centimetres on the big triangle. It has to be in that proportion.
Oh right, yeah, okay.
That's basically it, 2 is to 5. Doesn't matter which side you're talking about, because the corresponding sides have to be in the same proportion. So basically, if it's in between the red angle and the blank angle on one triangle, and it's the same one on the other triangle, it's got to be in the same proportion. This, for every 5, this one has, the other smaller one has 2.
Could you use half base times height for the last one?
No, it's not a right angle triangle, so you only did it for a right angle triangle. Here goes this one here. Write down the corners of the points A, B, and C. Okay, whatever. 2, 1. 2, 1. 5, 1. And 5, 5. Okay. Now, what else do we have here, guys? Triangle PQR is the image of ABC by a scale factor of 3. What does a scale factor of 3 mean?
3 times bigger.
3 times bigger. Now, how far away should that be from, how far should it be away from the centre? 3 times as far. Would you agree with that? It has to be 3 times as far away from the centre of enlargement. If it's 3 times bigger, it's 3 times further away. So look at the way to do this. If I go 5 across and 1 up, I get to the point B. I'm going to enlarge that 3 times, such that I'm going 15 across and 3 up. And that will give me the location of B dash. Likewise, for the point A, I'm going 2 across and 1 up. If I increase this by a factor of 3, I'll go 6 across and 3 up, which will bring me up to here. And finally C, which is 5 across, 5 up. If I increase that by a factor of 3, 15 across, 15 up. And do we have enough room for that? I just about do. And all of a sudden, the new triangle formed is how much bigger than the old triangle? It's 9 blocks for the bottom side. It used to be 3. It's 3 times bigger in every way, shape, and form. Everybody cool with that? Yeah. It's your 3. If you increase the size of the triangle by a factor of 3, it means you're 3 times further away from the centre of enlargement. There's no way around that. You're 3 times further away from that. Okay. Now, are they similar triangles? Why are they similar triangles again? The angles are the same and the lines are just a certain amount bigger, okay? Now, calculate A to C. What is A to C? Sorry, A to C. Okay, that's an interesting one. We're going to do Pythagoras' theorem, aren't we? It's definitely right angled. How do we know it's definitely right angled?
Same line.
Same line, straight up, straight across. 3 across, 4 up. You do Pythagoras' theorem. X squared equals 3 squared plus 4 squared. X squared equals 25. X equals 5. Okay? You can all do that in your sleep at this stage. Now, what's PR then? P to R. So I actually have to label this properly. P is A. P is the same position as A. Q is the same position as B, and R is the same position as C. Okay, once P to R, what length is P to R? 15. What is it, 15? 3 times bigger, so it'll be 15 right there. What's the ratio of AC to PR? This is what you're talking about earlier, Sean. A to C is 5. P to R?
That's
15.
15.
Yeah. Now, what's the same deal? If I said for every €5 you get, I get €15. How do I say that in simpler terms?
For every 5 I have, you have
15? No. 5 to 15 means for every 5 I have, you have 15. So I want you to tell me how to write that ratio a different way. For every €1 you get, I get 3. Divide both sides by 5. So it's 1 is to 3 ratio. That corresponds to a scale factor of 3. If it was a scale factor of 4, it would be 1 is to 4. If it's a scale factor of 5 over 2, what's the ratio? 2 is to 5. If it's a scale factor of 7 over 3, 3 is to 7. Okay, hit that point home. Calculate the ratio of the area of the first one when compared to the ratio of the area of the first one compared to the area of the second one. Well, actually, we can just do k squared, can't we? What's k squared? 9. So the ratio of 1 is to 9. The second triangle is going to be 9 times the area of the first triangle. Or you could calculate both areas and divide one by the other. These ones, without the diagrams, written examples tend to. Good job. Now, Kenny painted 2 similar rooms with the same paint. One tin of paint can cover roughly 10 meters squared. One tin, 10 meters squared. The smaller 2 rooms needed exactly 2 tins of paint. Each length in the larger room is 1.8 times larger than the corresponding length of the smaller room. How many tins of paint can you need to paint the larger room? Any idea about this one? Imagine you have two rooms, okay? Are we cool with that? 2 rooms. One room is 1.8 times longer and wider than the other room. If you were painting a straight line, guys, if you were just painting a straight line such that the second green line is roughly, it's like a blind spot on the board. The second green line is 1.8 times bigger than the first green line. Is everybody happy with that?
Yeah.
Now, in a case like this, I would need, if I'm just drawing a straight line and we're talking one dimensional here, if we're talking one dimensional, I will need 1.8 times more paint for the second line than the first line. However, when you're talking 2 dimensions, an area, that's how much paint it takes you for the first one. But you can see that the second one, it's over twice the area to do the second one. Okay, it'll be more than twice the area. Okay? So, what we're saying is instead of using 1.8, you're going to use 1.8 squared. Because it's 2 dimensions. The area is k squared times bigger, which is 1.8 squared, which is 3.24 to the best of my knowledge. Anybody 1.8 squared? And how many tins of paint did we need? Well, if we needed 2 for the first one, we just multiply that by 2. So it's 3.24 times bigger, so 2 multiplied by 3.24. 0.48. Round down, guys. Round up. Why do you have to round up? Can't have 0.48 over 10. And the other reason is, if you have 6, you don't have enough. If you have 7, you have enough with a bit left over. Okay? Stuff like that, guys.
How come you can't have 0.48?
Because you either buy a can or you don't. It's discrete data. Discrete data is you either have it or you don't. You can't say you can have 0.48 of a tin of paint.
Okay, yeah.
You have to buy the full tin or you don't buy anything. Okay, guys. Enlargements on photocopiers. Large reading on the photocopy is 100% when the copy is to be the same size as the original. Okay? When the reading is 110%, then each length is increased by 10%. What enlargement reading can you use if you want each length to decrease by 30%? 0.7, isn't it? Or 70%, sorry. So if you want it, you go for 70% if you want it to decrease, okay? An 8 centimeter line to increase to a 12 centimeter line. 8 to 12 divided by 8 is 1.5, which corresponds to 150%. And then finally a 15 centimeter line reduced to a 9 centimeter line. Maybe 9 divided by 15. Just 1 sec. 0.6. Okay, so 60% setting, okay? Yeah, you guys are alright with that. Alright.